The most dangerous volcano in America right now is not the one you are picturing. It is not Yellowstone. It is not Mount Rainier standing over Seattle, and it is not Mount St. Helens, the one that already blew. It sits about 300 miles north of Los Angeles, pressed against the eastern wall of the Sierra Nevada, hidden in plain sight beneath a ski town where tens of thousands of people sleep on a busy winter weekend. Its name is Long Valley. And most Americans have never heard of it, even though the ground there has been swelling, cracking, and breathing carbon dioxide up out of the soil for more than 40 years. The center of this valley has risen more than 2.5 feet since 1979. In May of 1980, it was struck by 4 separate magnitude 6 earthquakes, 3 of them on a single day. On the mountain at its western edge, so much volcanic gas is seeping up through the earth that it has killed entire stands of forest, more than 170 acres of trees, standing gray and dead where the soil itself has turned toxic. And in that same ground, 3 trained ski patrollers once died in a single morning without a mark on them. This is not a system that is asleep. It stirs, it goes quiet, and it stirs again. And scientists have spent 4 decades arguing about what that stirring actually means. Today we are going to break down exactly what is happening beneath Long Valley, where it is most dangerous, and whether things could get even worse. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now. Have you ever felt the ground move under you? An earthquake, a tremor, a jolt in the night? Tell me where you were and what it felt like. If you want to be the first to know every time something major happens, subscribe. It is completely free. A thumbs up also helps enormously. Let us go for 5,000 likes on this one, so the algorithm actually shows it to the people who need to see it. Now, let us get into it. To understand why a valley most people drive straight past is on a federal shortlist of the country's most dangerous volcanoes, you have to understand what it actually is. Long Valley is not a mountain. That is the first thing that trips people up. When you picture a volcano, you picture a cone, a peak, a crater, smoke at the top. Long Valley is the opposite of that. It is a hole. It is a caldera, which is the enormous bowl-shaped depression left behind when a volcano erupts so violently that it empties the magma chamber underneath it, and the entire surface collapses down into the empty space. And the eruption that carved this particular hole was not an ordinary eruption. About 760,000 years ago, this ground blew out roughly 150 cubic miles of molten rock in a matter of days. To put that number in context, the 1980 eruption of Mount St. Helens, the one that flattened forests and killed 57 people and is burned into the memory of everyone who lived through it, produced less than 1 cubic mile of material. Long Valley produced more than 100 times that. Glowing avalanches of superheated ash swept across east central California. Ash from the blast drifted on the wind and settled as far east as Nebraska. And when the magma chamber below finally emptied out, the roof of the earth sank more than a mile straight down, leaving a bowl about 20 miles long and 11 miles wide. Geologists have a specific, unglamorous word for an eruption on that scale. They call it a supereruption, which means the uncomfortable truth is this: Yellowstone is not America's only supervolcano. It is simply the famous one. Long Valley is the other one. And by the time we are done here, you will understand exactly what those earthquake swarms and that rising ground are really telling us. Because the honest answer is stranger, and in some ways more reassuring than the headlines suggest. For most of recorded history, none of this mattered to anyone living nearby, because the valley sat quiet. That ended in 1978. In October of that year, a magnitude 5.4 earthquake struck about 6 miles southeast of the caldera, snapping 2 decades of near-total seismic silence in eastern California. It was a warning shot, though nobody read it that way at the time. Then came May of 1980. Over a span of just a few days, the region was hammered by 4 strong magnitude, 6 earthquakes, 3 of which struck on the same day. For a place that had been asleep for 20 years, that changed fast. Scientists from the United States Geological Survey went straight to the valley to figure out what was happening, and when they got there and started remeasuring the ground, they found something they were not expecting. The floor of the caldera had bulged upward. The central part of the valley, a broad section geologists call the resurgent dome, had risen almost a foot since the summer of 1979, after decades of sitting perfectly still. Something was pushing it up from below. And there is really only one thing that lifts 100 square miles of solid ground by a foot: pressure. New material, forcing its way up beneath the surface. The swelling did not stop there. It kept going, on and off, for years, until by the early 2000s, the center of the caldera had risen roughly 2.5 feet in total, warping an area of more than 100 square miles. Now, here's where the human side of this story gets complicated. In 1982, faced with strong quakes and a rising valley floor sitting directly beneath a growing resort town, the USGS issued a formal public notice warning that the area had the potential for volcanic hazard. Scientifically, it was the responsible call. On the ground, it landed like a bomb of a different kind. Property values in the town wobbled. Tourism took a hit. Some residents were furious. They felt the government had scared away their livelihoods over a threat that never materialized. And that reaction matters, because it is part of why this valley is watched so carefully and communicated so cautiously today. The people who study Long Valley learned a hard lesson about the gap between what the instruments detect and what the public hears. So let me be very clear about something before we go any further. Rising ground and earthquake swarms at a caldera are real signals worth watching, but they are not, by themselves, a countdown to an eruption. Calderas can inflate and deflate and shudder for decades, even centuries, without erupting at all. The fear here lives in the facts, and the facts have to be handled honestly. So let us look at what is actually pushing that ground up. Beneath Long Valley, at a depth of about 12 kilometers, roughly 7.5 miles down, sits a large body of magma. We know it is there because scientists have now imaged it in remarkable detail. In one recent study, a research team ran a fiber optic cable roughly 100 kilometers long across the caldera and used it as a giant seismic sensor, a technique that turns an ordinary strand of glass into thousands of listening points along its length. What they found was a clear separation between two systems: the deep magma chamber far below, and a shallow hot water system much closer to the surface. And this is where the central scientific argument about Long Valley comes into focus, because there are two competing explanations for what has been lifting the ground and rattling the town. The first explanation is the frightening one: fresh magma rising up into the crust from below. The second explanation is more subtle. As that deep chamber slowly cools and crystallizes over thousands of years, it squeezes out hot, pressurized fluids and gas, a process geologists sometimes call second boiling. And those fluids migrate upward and outward, pushing on the rock and setting off earthquakes without any new magma moving at all. These are two very different stories. One describes a volcano reloading. The other describes a volcano slowly dying, wringing out its last pressurized fluids as it hardens into stone. Scientists generally do not claim to have this fully settled, and the distinction matters enormously, because it is the difference between a system building towards something and a system winding down. But here is the part that most people miss entirely, because it has nothing to do with a distant future eruption and everything to do with a danger that is already here, already killing, and completely invisible. To find it, you have to leave the caldera floor and climb the mountain on its southwestern rim. Mammoth Mountain, a lava dome complex that is itself a volcano, one that last erupted around 57,000 years ago and forms the backbone of one of the busiest ski resorts in the American West. In the spring of 1989, a swarm of small earthquakes began rattling directly beneath Mammoth Mountain, and it did not stop for months. The pattern of those quakes told scientists that a small body of magma, a thin blade of molten rock called a dike, was rising up inside the mountain. The magma never reached the surface. It stalled underground, but it left a signature that is still with us today. Not long after that swarm, Forest Service rangers started noticing something wrong on the flanks of the mountain. Trees were dying, not a few trees, whole patches of forest, going brown and gray and bare. At first, everyone assumed it was drought or beetles. It was neither. When USGS scientists ran a soil gas survey, they discovered the roots of those trees were being suffocated by extraordinary concentrations of carbon dioxide seeping up out of the ground. In healthy soil, carbon dioxide makes up less than 1% of the gas between the grains. In these tree kill zones, the soil gas measured anywhere from 20% to a staggering 90% carbon dioxide. The source was the magma that had intruded in 1989, quietly exhaling gas up through the fractured rock. Today, those dead zones cover about 170 acres, spread across 6 areas on the mountain, and the ground there breathes out somewhere between 50 and 150 tons of carbon dioxide every single day. To understand why that is genuinely dangerous, and not just an ecological curiosity, you have to know one physical fact about carbon dioxide. It is heavier than air. It does not rise and disperse. It sinks. It pools. It collects in low spots, in hollows, in snow wells around tree trunks, in depressions, and in any poorly ventilated enclosed space. A tent, a cabin, a snow cave, a pit dug into the snowpack. Breathing air with more than about 7% carbon dioxide can cause a person to lose consciousness and die, and it can happen fast, without warning, without pain, without the rotten egg smell people associate with volcanic gas, because carbon dioxide has no smell at all. There are places on that mountain where locals use a chilling word borrowed from Africa for exactly this phenomenon. Mazuku, meaning evil wind, the name given to invisible pockets of ground-hugging gas that can kill in minutes. And it has killed. In 1998, a healthy cross-country skier was found dead in the Horseshoe Lake area, his death attributed to breathing carbon dioxide gas. But the day that seared this hazard into the mountain's history came in April of 2006. That winter had buried the region under a record snowpack, more than 50 feet of snow on the mountain. On the morning of April 6th, a little after 11:30, 3 members of the Mammoth Mountain Ski Patrol went to re-secure the fencing around a known fumarole, a vent in the ground that releases volcanic gas. Under all that snow, the vent had opened a hidden cavity. The snow at the edge gave way, and one patroller dropped roughly 21 feet down into the bottom of the pit, into air that was lethal within minutes. A second went in to save the first. Then the third followed to save them both. All 3 died from the gas. A rescue team eventually had to descend into the fumarole wearing masks just to recover them. 3 trained professionals, on a mountain they knew intimately, killed in a single morning by a gas they could not see, could not smell, and could not outrun. Now, in the interest of the full picture, here is the honest counterweight, because this is exactly where responsible reporting and fear-mongering part ways. The carbon dioxide emissions on Mammoth Mountain are not accelerating. In fact, the discharge appears to have peaked back around 1991 and has generally been declining since. The town of Mammoth Lakes itself, just east of the mountain, has not been affected by the tree kill gas. The deadly pockets are out on the flanks and in the backcountry, which is exactly why they are fenced, mapped, monitored year-round at multiple sites, and marked with warning signs. This is a known, contained, watched hazard, not a spreading catastrophe. But it is a permanent one. As long as there is magma cooling beneath that mountain, it will keep breathing, and the danger will remain for anyone who wanders into the wrong hollow after a heavy snow. That is the strange dual nature of Long Valley. Its most dramatic threat, a supereruption, is extraordinarily unlikely in any human lifetime. But its quiet threat is real, it is present, and it has a body count. So who exactly is living on top of all this? The answer is what makes Long Valley matter far more than an obscure caldera in the high desert has any right to. The town of Mammoth Lakes, home to roughly 7,000 year-round residents, sits directly against Mammoth Mountain, and on a peak ski weekend that population can swell many times over as visitors pour in from across California and beyond. The caldera floor itself hosts a working geothermal power plant at Casa Diablo, tapping the very heat that makes this system dangerous and turning it into enough electricity for around 40,000 homes. U.S. Highway 395, a critical artery up the eastern side of the state, runs straight through the hazard zone. This is not empty wilderness. It is infrastructure, homes, and tens of thousands of people sitting inside and beside an active volcanic system that has produced, in its deep past, one of the largest eruptions in the geologic record of North America. And that is precisely why the response to Long Valley has not been to evacuate it or to ignore it, but to watch it more closely than almost any other volcano in the country. So, after 4 decades of swelling ground, earthquake swarms, and lethal gas, the open question we started with: what is Long Valley actually doing right now? Here is where the honest answer surprises almost everyone, because it runs in the opposite direction of the alarm. In recent years, the caldera has been remarkably quiet seismically, and the ground, which spent so long rising, has switched. It is no longer inflating. It is subsiding, slowly sinking back down. This shift was significant enough that the California Volcano Observatory carried out its most extensive ground survey of the caldera since the late 1990s, precisely because a change like that, even one that points away from danger, needs to be documented in detail. And when researchers on that fiber optic imaging study interpreted the deep chamber, their conclusion leaned toward the second, less frightening explanation. The unrest, they argued, is most likely being driven by fluid squeezed out of a magma body that is slowly crystallizing and cooling. A system one team described, in plain scientific language, as moribund. Dying, not reloading. So does that mean it is over? That Long Valley is finished and safe? No. And this is the last, most important piece of honesty in this whole story. Those same scientists were careful to add a caveat that you should hold on to. This interpretation does not rule out the possibility that a fresh injection of magma from deeper in the mantle could disturb that cooling chamber and, in their words, revitalize the system. A supervolcano does not send a schedule. It can sit moribund for tens of thousands of years and still be capable of surprising the people who study it. And even if it never produces another great eruption, it does not have to. It has already shown, again and again, that it can rise, it can shake, and it can breathe out something deadly. That combination, an enormous, restless caldera underneath a resort town, currently quiet but never truly settled, is exactly why the federal government's National Volcano Early Warning System classifies Long Valley's threat potential as very high. Not because an eruption is coming, but because if this system ever does stir in earnest, it will happen where thousands of people live, and the only thing standing between a signal and a disaster is how closely we are watching. Keep an eye on a few things going forward. Watch the earthquake swarms along the southern edge of the caldera. Small, felt jolts still turn up there, and their rhythm is one of the clearest windows into what the fluids underground are doing. Watch the carbon dioxide flux on Mammoth Mountain, because any real reversal of that long decline would be worth paying close attention to. And watch the ground itself. The moment subsidence turns back into sustained uplift, the scientists who monitor this valley will be the first to know, and they will say so. Because the difference between Long Valley and a catastrophe is not luck, it is monitoring. It is a network of instruments, fiber, and geologists that did not exist when this valley first stirred in 1980, and that now watches it in a detail that would have been unimaginable back then. If this breakdown gave you a clearer picture of the quiet giant under the Sierra, the supervolcano that isn't Yellowstone, do me a favor and hit that like button. Let us get to 5,000 so this reaches the people who ought to see it. Let us go. See you in the next one.